Okay, so let's see how you did on these. For the first one, tell me where to start. Okay, so we've got 4x squared times 3x to the fifth, which is 12x to the seventh. Good. Remember, 4 times 3 is 12. You multiply the counts, or the numbers, and then you also multiply the names. X squared times x to the fifth. Remember, when we multiply variables with powers, we add the powers. And then 4x squared times negative 7x squared is negative 28 x to the fourth. Good. Then moving on, we have, this is not 5x to the third, but negative 5x to the third times 6x to the fourth is negative 30 x to the seventh. Good. 3 plus 4 makes 7. And negative 5x to the third times a negative 2x is positive 10 x to the fourth. All done? No, what do we have to do? Okay, so we've got 12x to the seventh and a negative 30x to the seventh. So we've got a positive 12 and a negative 30 makes negative 18x to the seventh. Good. When we're adding or subtracting, we keep the same name, so the power doesn't change. Anything else? Perfect. Negative 28x to the fourth and positive 10x to the fourth. Negative 28 and positive 10 makes negative 18 x to the fourth. So negative 18x to the seventh minus 18x to the fourth is what we get. How many of you had that? Good deal. Any major questions on where that came from? Okay, number 2. This one's a little different. Now you could just distribute twice here. You could take the 3x and you could multiply that through, and then you could take the negative 7 and multiply that through. That works. Kind of similar to the FOIL method if you want to use that. But another way we could do this is just set it up with the number with the most digits, which is this one, on top. Then putting the other one on bottom. And then we're just multiplying like we would with whole numbers. So negative 7 times 3 is negative 21. Negative 7 times negative 5x is a positive 35x. Good. Negative 7 times 2x squared. Negative 14x squared. Good. Now we come over to the 3x. 3x times 3 is 9x. So that's going to go underneath the other x here. So underneath the 35x. 3x times a negative 5x. Negative 15x squared. Good. X times x makes x squared. And 3x times 2x squared. 6x to the third. Good. X times x squared is x to the third. So now we've got the negative 21. 35x and 9x makes a positive 44x. They're both positive, so we're just going to add them. Negative and a negative. Well, negative 14 and negative 15 is just going to be a negative 29x squared. And 6x to the third. Anybody have that one? Just a couple of you? Okay. That one's a little trickier. Okay, well, as far as the tests from last Thursday, I have 3 people yet to finish those. So I'm not going to get those graded until I have all of them in. So hopefully we'll have those in and graded by Thursday for you. But what we just went over here is a good bridge into our new material. You know, we saw something like like this. And of course, we just multiplied that out. We distributed is the word for the shortcut for it. We took 7x squared times 5x, give us 35x to the third. And 7x squared times negative 3 gave us a negative 21x squared. Now we've done something with whole numbers called factoring. And when we were factoring a whole number, we might have had something like 15. We split it into two numbers that multiplied to make 15. Well, 3 times 5 is 15. Now, in this case, you can't split them up any further, so we would have been done there. With a polynomial, you can always split it up further because you can split up the variables, or not always, but you can usually split it up further. So what we do with a polynomial like this when we go to factor is we just take out the largest common factor, or the greatest common factor. Remember, we called that the GCF. So what that means is we look at the digits of our algebraic number here, of our polynomial, and we find that common factor of the numbers and the variables. So what we're looking at is the digits here. We have 35x to the third and 25x squared. So let's just look at the numbers, the 35 and the 21. Can anybody look at those and see the greatest common factor? 7. Very good. Now, if you didn't see that, you would factor. 35 is 5 times 7. 21 is 3 times 7. So the only common factor is the 7. So that's our greatest common factor. If there are more than one common factors, we'd multiply them together to get the greatest common factor. What do we do with the variables? For GCF, it's either the largest power or the smallest power. For greatest common factor, a factor must be smaller than the numbers, right? Like 7 is smaller than both 35 and 21. So it means we're taking the smaller of the powers. So what is the smaller power? X squared. Good. 7x squared is our greatest common factor for those two digits. So if we were asked to factor this, remember when we were doing those factor trees, if I had my 15 and I decided I was going to take out a 5, how did I find the number that went over here? I divided. 15 divided by 5 gave me 3, so I put 3 there. So the same thing is going to happen here. I have 35x to the third minus 21x squared. I decided that 7x squared is one of my factors, right? To find the number that goes here, I'm going to divide this by 7x squared. So what is 35x to the third divided by 7x squared? 35 divided by 7 is 5. X to the third divided by x squared is just x. 3 minus 2 is 1. So x to the 1 or just x. So then negative 21x squared divided by 7x squared. Negative 21 divided by 7 is negative 3. X squared divided by x squared cancels out, so it's not there. So the factoring of 35x to the third minus 21x squared is 7x squared times 5x minus 3. Now in this case, we started out by multiplying that out, so we can verify that that's right. We split it back up. So let's try it when we don't watch it get put together. So we might look at something like this. So when I look at that, the first thing I have to ask myself is, what is the greatest common factor of 24 x to the 5th and 36 x to the 3rd? Careful, 8 does not go into 36. You have the right idea, though. If I do a factor tree for 24, I get 2 times 2 times 2 times 3. For 36, I get 2 times 2 times 3 times 3. What do they have in common? A 2, another 2, and a 3. 2 times 2 is 4 times 3 is 12. So the number is 12. X to the 3rd, the smaller power. So 12x to the 3rd is the first part, or first factor. So to get the second factor, we're going to divide by 12x to the 3rd. 24x to the 5th divided by 12x to the 3rd. What's 24 divided by 12? 2. X to the 2. 5 minus 3 is 2. 36x to the 3rd divided by 12x to the 3rd is positive 3. 36 divided by 12 is 3. Anything else? X to the 3rd divided by x to the 3rd cancels out. So that is simply 12x to the 3rd times 2x squared plus 3. What do you think? Better than a sharp stick in the eye? Maybe? Okay. I'm going to have you guys try one. Give that one a shot in your notes. What'd you get for your greatest common factor? Seven x to the 3rd, right? How many of you got that for your greatest common factor? Okay. So now we've got to divide that out to see what's left over. 35x to the 4th divided by 7x to the 3rd is 35 divided by 7 is 5. X to the 4th divided by x to the 3rd. Well, x to the 4 minus 3 is 1, so just x, or x to the 1 if you wanted to. And then negative 21x to the 3rd divided by 7x to the 3rd. Negative 3. That's it. Anybody have that? Let's try another one just to see if you're on your toes. Give that one a shot. Okay. Where do we start? 5 is part of our greatest common factor. What's the rest of it? X to the 6th. Y to the squared. Good. It has to be the smaller power for each of the variables. So we're going to divide by 5x to the 6th y squared. 45 divided by 5 is 9. X to the 8 divided by 6, 8 minus 6 is 2. Y divides out. Y squared divided by y squared is gone. It cancels out. 35 divided by 5. Positive 7, so plus 7. X divides out y to the third. Any questions? How many of you had that? Just getting there, just running out of time? Okay. Adding that extra variable in there does not change anything. You're still looking for the lowest power of each variable. So you have x to the 8 and x to the 6th. Well, 6 is smaller. Y squared and y to the 5th. Well, squared, or 2 is smaller. A lot of people think you got to take the variables both from the same term. You don't. It's still the smallest one of each one. So that is called factoring by the greatest common factor, or GCF method. And if you're going to factor a polynomial, or factor an algebraic number, that is always the first step. Step number 1 is to look for a GCF, greatest common factor. If there is not a greatest common factor, or after you have taken out a greatest common factor, the second step depends on how many digits or terms are in that algebraic number. If there are 3 digits or 3 terms, we're going to use something called reverse multiplication. Sometimes, for those of you that took a traditional algebra course, called FOIL in reverse. If there's 4 terms, we would use something called grouping, which we may not deal with in this class. If we have extra time, we'll maybe take a look at an example of it. So let's take a look at this next step. And I'm going to start out with the easiest possible example I can think of. Let's say I have x plus 3 times x plus 5. Now we do have that FOIL method, the first, outside, inside, last, but we really didn't stress that in here. What we did was simply multiply it out like we would any whole number. So 5 times 3, positive 15. 5 times x is 5x. Well, then we move over to the x. X times 3 is 3x. So we put a positive 3x in there underneath the 5x. X times x, x squared. So that's positive 15. 5 and 3 make a positive 8x and x squared. So we multiplied that out to get x squared plus 8x plus 15. Now, if I were asked to factor that, first thing I would look for is a greatest common factor. Right away, this one tips me off that there is no greatest common factor. Because what's the number in this first digit? There isn't one there, which means it's a 1, right? Well, 1 doesn't have any factors, does it? So there's no way that there's a common factor for the numbers, because one of the numbers is 1. Is there a common factor for the variables? No, because this digit doesn't have a variable. For a variable to be a common factor, it has to appear in every number, every digit. Just like up here, there was an x in every digit, so it was part of the common factor, and there's a y in every digit, so it was part of the common factor. If there isn't a variable, if that variable is not in every digit, it cannot be part of the common factor. So there is no greatest common factor for this one. There is no common factor period for this one. So since there is no common factor, we go on to that second possibility. This has 3 digits, so we're going to try to do reverse multiplication. Now if we look up here, where did this first digit come from? It came from multiplying the x times the x, right? Came from multiplying the first digit in each of the two numbers. So if I'm trying to reverse the multiplication here, I'm going to assume that this splits up into two-digit numbers that are multiplied together. And the x squared comes from these first 2 digits being multiplied together. So to get x squared, that would be x times x. Does that make sense? This last digit, the 15, comes from multiplying the 3 times 5. In other words, the last 2 digits together. Problem is, there's more than one way to make a 15. There's a 3 times 5, or there's a 1 times 15, isn't there? How do I know which one I want? Well, in this case, I know it's 3 and 5 because I multiplied it out to begin with, didn't I? So let's put the 3 and 5 in here. And of course, it's a positive 3 and a positive 5 because it's a positive 15. It could also, by the way, be a negative 3 and a negative 5 could make a positive 15 as well, because a negative times a negative is a positive. But anyway, how do we know for sure that the 3 and the 5 are what we want? Well, we can double check. This middle digit in our result here came from, if I'm looking at FOIL, right? Came from the outside and the inside. I multiplied the 5 times the x and the 3 times the x. So here, I would multiply the outside. X times 5 is what? 5x. And on the inside, I have 3 times x is 3x. If I add those together, I get 8x, which is what that middle digit is. That tells me that this is the right factoring. So now, let's try. This. First step. Is there a greatest common factor? No, there is not. So then we're going to try to do the reverse multiplication. So we're going to assume this splits up into two two-digit numbers. What's these first digits have to be? X times x. Why? Because they have to multiply to make x squared. What do these last 2 digits have to multiply up to? 12. So I've got some choices there. There's 1 times 12, 2 times 6, or 3 times 4. We don't know which one it's going to be until we pick one and test it. So let's try 2 and 6. And let's test it. What's x times 6? 6x. What's 2 times x? 2x. What's that add up to? 8x. Is that what we want? No. So that is not correct. The 2 and the 6 do not work. Next, let's try 3 and the 4. So, x times 4, 4x, 3 times x, 3x adds up to 7x, which is what we want. So, that's x plus 3 times x plus 4 is the factoring of that. Does that make sense? How about here? What's the first thing I see? Yeah, step one is always look for greatest common factor. Is there a greatest common factor here? Eight. 8, 8, and 16 can all be divided by 8. So if I divide by 8, what's left over? What's 8 divided by 8? 1. So that's just going to be x squared, right? What's 8x divided by 8? 1x, so just x, so positive x. Negative 16 divided by 8. Negative 2. Now that we've divided out that greatest common factor, the 8, we still have to check to see if this can be factored any further. It's 3 digits, so we're going to try to do that reverse multiplication. Now remember, if I had something like 24 and I split it up, let's say I took out a 2, I took 24 divided by 2 to get 12, right? I could still split up the 12, couldn't I? So my factors, the 2 is still a factor. It's just whatever I split the 12 up into stayed with it. So that 8 is still a factor. We just have to try to split this up into other things. So x times x would make x squared. To make a negative 2, it's either going to be 1 times a negative 2 or negative 1 times a positive 2. Which one do you want to try? Positive 1 times a negative 2. Let's try that. So what is x times negative 2? Negative 2x. What's 1 times x? Positive 1x makes negative 1x. Is that what we want? No, we want a positive x or positive 1x. So let's try a negative 1 and a positive 2. X times positive 2 is 2x. Negative 1 times x is negative 1x. 2x and negative 1x make 1x or just x, which is what we want. So that does give us a correct factoring of that. So the x squared plus x minus 2 does split up into x minus 1 times x plus 2, and we still have that factor of 8 there yet. What do you think? Are you having fun yet? No? Oh, come on. At least pretend. Make me feel good. Okay, there you go. See? Now you got the spirit. So for this one, any common factors? It looks like there should be because you got the 8 and the 12. But this is a 1 here, which means there are no numbers. How about for the variables? No, there's no variable on this last term, so there are no variables in a common factor. So there is no common factor here. So our next step, try to do the reverse multiplication. What's the first number have to be here for each of them? X times x to make the x squared. These two have to multiply to make 12, right? So I'm looking at 1 times 12, 2 times 6, or 3 times 4. Or it would also be positive if it was a negative 1 times a negative 12, and a negative 6 times a negative 2, and a negative 3 times a negative 4. Why am I bringing that up? Because this adds to a negative 8, which means I'm probably going to be dealing with negatives somewhere. So which ones do I want? Okay, so negative 2 and negative 6. Some of you might be starting to see a pattern here. These two multiply to make the 12, but they also add to make the negative 8, don't they? Let's test it. X times negative 6. negative 6x. Negative 2 times x, negative 2x. Negative 6 and negative 2 add to make negative 8x. Is that what we want? Sure is. What do you think? I want you to try this one in your notes. See what you come up with. Okay, so first of all, are there any common factors? The correct answer would be no, right? So now we're going to try to split it up. What's the first digit of each going to be? Y and Y. Y times Y makes Y squared. Now these last digits have to multiply to make negative 24, which means one's going to be positive and one's going to be negative. So now I've got 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Which one do I want to try? Anybody want to throw one out? 3 and 8. So let's try negative 3 and positive 8. Remember, one had to be positive, one had to be negative. So now I try. Y times 8 is 8y. Negative 3 times y is negative 3y. 8y and negative 3y make 5y. Positive 5y. Is that what we want? No, we want negative 5y. We've got the right number but the wrong sign, which is probably telling us, yeah, the signs are wrong. If we make it a positive 3 and a negative 8, let's see what that does. So now y times a negative 8 is negative 8y. 3 times y is positive 3y. Negative 8 and positive 3 make negative 5y, which is what we want. So there it is. Anybody come up with that? So again, you see the pattern. These two have to multiply to make the negative 24, and they have to add to make the negative 5. Give this one a shot in your notes. Remember, step 1 is always look for greatest common factor. Good. Give that one a shot. First thing you see is that there is a greatest common factor, which turns out to be what? 2x. So if I divide by 2x, 2x to the third divided by 2x is simply x squared. 6x squared divided by 2x. Positive 3x. And 4x divided by 2x. Positive 2. So, excuse me. We still have to see if this can be split up any further here. So now the 2x isn't going to go anywhere. Well, let's see if we can split that up. Were you able to split it up, first of all? Yes? Okay. So the first digit's x times x to make x squared. The last two digits have to make 2, right? So it's either 1 times 2 or -1 times -2. Is there any indicator that would give us a hint as to which one? That's a +3. So it's telling us most likely a +1 and a +2. If we double check here, x times 2 is 2x. 1 times x is 1x, or just x. That adds up to be 3x, which is what we want. So we factor that to get 2x times x plus 1 times x plus 2. How many of you got that? Any major questions? Well then, I want to try another one for you. Try that one quick in your notes. See what you come up with. So when you look at this, is there a common factor? No. 49 is only divisible by 7. So there is no common factor here. So that means we go to try to split this up. These first two digits have to multiply to make 4x squared. Your reflex is to try 2x times 2x, isn't it? That makes 4x squared. These last two digits have to multiply to make 12. So you've got 1 times 12, 2 times 6, 3 times 4, right? Which one do you want to try? 3 times 4? Okay, let's do 3 times 4. Now it's either +3 times +4 or -3 times -4 because it's a +12. We're going to, since this is a +49, we're going to go with both positive. So on the outside, 2x times 4 is 8x. On the inside, 3 times 2x is 6x. That adds up to 14x. Is that what we want? No. Would it make any difference to switch the 3 and the 4? No, because it's going to be the same anyway. So now let's try 2 and 6. So now on the outside, 2x times 6 is 12x. 2 times 2x is 4x. That makes 16x. Is that what we want? No, but it's closer. So let's try 1 and 12. So now on the outside, 2x times 12 is 24x. 1 times 2 is 2x, makes 26x. Is that what we want? No. Does that mean this one can't be done? No, there's another possibility. Instead of 2x times 2x, how about 4x times 1x? And now let's try 12 and 1. So we multiply. What's 4x times 1x? Or 4x times 1, I should say, is 4x. 12 times x is 12x. That adds up to make 16x. Not what we want. But can we switch the 12 and 1 here and make a difference? Yeah, because these are different. The 4x and the x are different. If I switch the 12 and 1, it will change the result. So now I have 4x times 12 is 48x. 1 times x is 1x. That adds up to 49x. That is what we want. Sometimes this is just an exercise in exhausting the possibilities until you find one that works. Try that one. Anybody find an answer yet? If I were to ask you to factor 17, what would you come up with? You can't. 17 is prime, right? This is prime. There are no common factors. X squared is going to be x times x. No matter what I put here, there is nothing that will multiply to 12 and still add up to the 10. I can try the 1 and 12, 2 and 6, 3 and 4. Nothing will work. How's everybody doing? Good? Okay, well, this is a great point to take a break. So let's do that. It's 9:59. Let's come back at 10:09. Actually, it's 10 o'clock now. Let's do 10:10.